Hello everyone. I want to give you some helper videos here that I think will prove worthy and helping you be successful with the completion of assignment number 4. There's questions above these requirements here, so you're responsible for the chapter questions. I'm not going to go over that, and I'm not going to go over the business rules very much as well either, because I want to keep the videos as short as possible. I did go over the business rules in class. One thing I do want to draw your attention to is the DBMS that we'll be using. We have used MySQL, the MySQL DBMS in the past, the database management system. We'll be using Microsoft SQL Server, Microsoft SQL Server for this particular assignment, and you can access it here. If you go to the class site, let me bring that up. Also, we'll be showing the actual ERD for A4 as well too. But if you go to the class site and go to the notes section, which this may appear differently in a future course, but I still will have some type of a notes section. If you go to the notes section and you go there and grab, take a look at, here are the MS Microsoft SQL Server login procedures. Just follow the login procedures right here. I have created databases for each of you based upon your FSU ID. For Mac users, here's a video right here that you could take a look at. For Windows users, you can just follow the instructions over here. Okay? Have any questions, please post them to the discussion board or send me an email. Going back to the assignments, whenever you have the luxury, gang, of having the ERD at your disposal, like we did for assignment number 3, project 1, I showed that, but project 1 in particular I posted here because it was fairly large. Assignment 4, same thing, even larger. So whenever you have the luxury of the ERD at your disposal, take advantage of it because it will greatly help you generate your SQL statements to create your tables and populate your tables with data. Briefly, again, go over the business rules here just in a cursory fashion. We're talking about a high-volume home office supply company. We essentially have a customer and or a buyer-seller scenario here. A little more elaborate design than we've been used to, but essentially a buyer-seller scenario. If you look here, I tried to visually split it off for you so that you could see so buyer is above here, and when I mean above, I don't mean inclusive of the orange. Really what I mean is above order line and order, and everything in the blue here is really associated. We're talking with the buyer, and the buyer here is also associated with the sales rep. So we're using a specialization hierarchy, inheritance. A sales rep is a person, a customer is a person. So we're going to cut down on the attributes, and we're going to use a specialization hierarchy, which I did talk about in class. Everything above this line here is associated with the buyer section. Everything below it, including the orange, is associated with the seller. So we have 6 tables here associated with the seller, and then we have 8 tables here associated with the buyer, including the relationship between the sales rep and the customer. Okay, and I did talk about it in class. If you have any questions that you would like to discuss concerning the business rules, please feel free to post them to the discussion board or email me. Also have some notes here to help clarify the business rules. Also, if an order is canceled, it is deleted, and it's optional participation here. So essentially, if an order is canceled, it is then deleted. It's not part of the invoice. What else we're going to do here is SHA-2 hash values, just like we did in a previous assignment. Only here we're going to do it with SQL Server. We did it before, SHA-2 512 hash values. With MySQL, we're going to do it now with SQL Server. You see, it's a bit different the way we have to implement it. Again, just further clarification about the requirements of the design, how to log in here. With this link for SQL Server, and again, I have that information for Mac users as well too. Please see the notes section for Mac users. We're going to use the SHA-2 512 hash values for Social Security numbers. Also, we're going to include a little bit more of doing data constraints, which we can in SQL Server, and there's other ways we can work around in MySQL as well too. But one easy way in SQL Server is similar to using regular expressions, and that is to indicate how many digits do we want. For instance, for zip code, it would be 9. So each one of these is essentially similar to a regular expression class, indicating that the only good values for each one of those 9 digits would in fact be 0 through 9. Same thing with phone, only it would be 10 of these classes here. For phone type, we're going to allow fax, F for fax, W for work, C for cell, phone, H for home, and just a minimal constraint on your sales rep. Your sales goal is have to be greater than or equal to 0. One thing, the person table must have at least 10 records, and that would mean that all the other tables could have 5 records. So the person table must have 10, and all the other records can have 5. I'm sorry, all the other entities could have 5 records. There we go, deliverables, ERD, SQL statements, and here is our the reports that we're going to be writing. So we'll have that, and that's about it. So let's begin with the Transact SQL, also known as T-SQL. Another thing I want to mention is that if you want to use Table Designer, which is very similar to Access, the Access interface, feel free to do so, but you're going to have to research that on your own. I will say this, though. If you want to use it, have at it. But you'll see that in the long run, using T-SQL 1 is actually many times faster than trying to use the Table Designer. Number one. Number two, it gets you acclimated to using T-SQL, so you're not constrained to an interface. And number three, you could always back up everything in another file much more readily and much more simply using T-SQL than in Table Designer. Okay, from here, let's begin. I have my code here, and you should be able to see everything. I'll bump that up one more notch. There you should be able to see everything. I just have notes here. Also a question, why do we use DBO? And DBO stands for database owner, and I just put some comments here. For my research, even if the SQL code doesn't have to use the fully qualified name, for instance, dbo.customer, you just use customer instead, like we would with MySQL. From my research, evidently there's a slight performance gain in doing so. And again, it's because the optimizer doesn't have to look up the schema. And it's also considered a best practice. There's a link there if you want to take a look at it and why we use DBO in front of our table names. All right, gang, this is it. Let's go. I'm just going to show the SQL here, and then we're going to go to the the create statements and populate statements. Then we're going to go to the reports. All right. This is similar to show warnings in MySQL, not quite the same, but similar to showing warnings. Always make sure that you use master and avoids the error that you would get if you had an open connection and you were trying to delete your database while you were still in your database. So always use master first. Go is just a T-SQL command. It's like batch processing. So you would say go after various commands. You don't have to, but it just makes it cleaner, particularly if you're using multiple commands. That way that at least some of the commands would process while others that had errors may not process. But that's why you would use go after each series of commands. Excuse me. Go, drop the existing database if it does exist. Excuse me. Gang, wherever it says mjoet, please, again, use your FSU ID, okay? Wherever it says mjoet, just supplant your FSU ID there. So you're going to drop the existing database if it exists, create it if it doesn't exist, and then, of course, what you want to do is just use your database, just like we would, very similar to MySQL, right? So there's the commands there. And just some comments here about what the I did talk about this in a previous class in 3784. The reason why we use the N here, you don't have to with normal Latin character set. But if you're trying to make this a global application or a global database design, you want to use the N apostrophe. What that does is it makes sure that it allows for Unicode values. And this is particularly important for Cyrillic languages or non-Western type languages, that you can make it for a global environment. The N indicates that it would be conformed to Unicode characters. And then, of course, make sure you use your database. Be sure to create and populate in a correct order, gang. That's important. You must create these tables. You must create these tables from strong tables to weak tables, or strong tables to existent dependent tables. So in other words, you wouldn't put the create statement for sales rep and customer before person. You'd have person first, then sales rep, then customer, then phone. You could have sales rep, of course, has to come before sales rep history. Product has to come before product history, etc. So you want to do the strong tables, the existent dependent tables, the existent independent tables, pardon me. The strong tables are existent independent tables like vendor and person before the existent dependent tables like product history and sales rep history, etc. Even store here in this design at this point anyway, before we get into our data store in the next assignment, our little mini data warehouse, even store here is a strong table. Okay, so let's do that. By the way, again, here I indicate what exactly some of this code is. I have a legend here so that you can understand what those various characters means. The U is for only to look up objects that are tables. So that's what the U stands for. And so, again, be sure to use DBO before all table references. Okay, let's begin with the person table. So we've seen this before in 3784. The N, again, we're just, if the object is everything in SQL Server and Oracle and even MySQL really is an object. So if the object ID of the person table exists, is not null, then we're going to drop it. Okay, then we're going to create person. So I'm going to keep this all together. And here's the code for that. I highlight it while I'll talk about it. Remember, gang, there is no such thing as enums in SQL Server. So what we do instead of that, instead of using enums, we do something like this. We could use a check constraint to make sure that in the person gender attribute that only M or F is allowed. And by the way, that's case insensitive. So either capital M or lowercase m, capital F, etc. are valid. Look at the person's zip code. Now, this is how we could do a check constraint to make sure that the zip code only contains 9 digits, and again, they have to be numeric values based upon those classes for each digit, 0 to 9. We're doing a check here. By the way, this is our subtype discriminator, right? The person table is entity is a supertype, and the per type is a subtype discriminator, using the enum values of C or S for customer or sales rep. So this is our subtype discriminator. Again, here is our person table, and we're going to have a unique constraint on Social Security number. Later on, I'll show you in this code how we make that Social Security number hashed SHA-2-512 hash value. But we're going to make it a unique value because we want to make sure that our Social Security numbers are unique. Okay, so because a person can have multiple phones, customer or sales rep, we're going to have a person table to eliminate the need for including the multiple phone values in a customer table or in a sales rep table. We just keep it all in a phone table. That way we don't have any null values. If a customer or sales rep doesn't have a phone, they're just not included in that phone table. If they have 10 phones, they're included 10 times in the phone table. All right, there's the code there. So I'm not going to replicate what I discussed in a previous table. You could see that we're doing the same thing with phone number, making sure they're 10 digits. The phone type is H for home, C for cell, W for work, F for fax. And we have a foreign key constraint. What is it? It's the PER_ID. That's our foreign key there. Notice phone has its own primary key. However, the subtypes of sales rep and customer do not have their own primary keys. They have a primary key, but it's inherited from the person table. So PER_ID and the customer table and PER_ID and the sales rep table are inherited by the primary key in the person table. All right. There's phone. Here we're going to do customer right now. Okay. And customer is very small. Why? It's because the beauty about inheritance and the specialization hierarchy is we don't have to duplicate data. If we want to find out a customer's name, we do a join between person and customer. Sales reps, year-to-date sales, we do a join from the person to the sales rep table to find out what their name is. Okay, so that keeps our attribute numbers down in those tables. So all we need here is the foreign key of person ID from the person table. Notice we're doing a constraint on both the customer balance and total sales. We're constraining it to a positive value. Now, it's not much of a constraint, but at least it keeps the numbers positive. Okay. Next, sales rep. Likewise, small table. Don't have to have F name, L name, street, city, state, zip. Only the year sales goal, year-to-date sales, year-to-date commission, and notes. There's the foreign key right there. We have constraints, making sure we have only positive values. Okay. They're on update cascade. And then here's the sales rep history. Notice because the sales rep history, what we're doing here, we have to keep track of the sales rep, so it's going to have the PER_ID. It has its own primary key, though, SHT. That could be an acronym for something else, or but it's not. It is just sales rep history ID. What are we tracking? The sales rep history type, insert, update, and delete. When it was modified, who the modifier was, the date, meaning the year of that sales rep history date, not the modification, but the year that we're tracking for their sales, the year sales goal, the year total sales, and the year total commission. Okay, that's that. Let's look at contact. Now, contact, I like to go back and forth here so you could see what we're actually doing. Contact is really a confluence of customer and sales rep. Now, a couple things here. We cannot have the PER, just like in Project 1, we cannot have the PER underscore ID listed more than one time. As a matter of fact, you can't have any ID with the same name or any attribute of the same name listed in the same table more than one time. So the PER underscore ID for customer is now PER underscore CID for the customer ID. It is a foreign key. Contact has its own primary key. And the foreign key for sales rep, here, remember, it's inheriting PER underscore ID from the person table, is PER underscore SID for the sales rep. So we have our foreign keys here, and then we have the contact date, which is a date time data type. So we have two foreign keys. There they are. Notice the date time data type for the contact date time. When did it occur? Because it could occur by the same customer can contact the same sales rep more than one time per day. Okay. Now, a couple things I want to talk about here. This is important. The reason why we have cascade on only one of these and no action on the other is so that we don't get into an issue where you have multiple cascading paths. And we have seen this in 3784 with a couple other assignments. But I'm going to show you this note here. You cannot have cascade paths on both foreign keys in contact because the records in contact table are linked with the customer records. And the records in the contact table are linked in the sales rep records. Even if records in the contact table never belong to both customer and sales rep, it would be impossible to make the contact table's records cascade delete for both customer and sales rep table because there are multiple cascading paths from the person to contact table. So one via customer and one via sales rep can't do both at the same time. So if you're trying to say on delete cascade a person, what it's going to do is going to delete the customer and delete the contact. Well, you would have a multiple issue here because when you delete a person, you're also deleting a sales rep. So you can't delete this twice. You can't delete the contact record twice. And that's why what you have to do here is only make one of these foreign keys on delete cascade, on update cascade, and the other one on delete no action, on update no action. If you want to see what would happen, once you get this working, try making this foreign key on delete cascade, on update cascade, or even just one of them. In other words, like this one, make this on delete cascade. You'll see that you'll get this error for multiple cascading paths. Okay? So be careful of that. Again, here's the contact table. Be careful of the foreign keys and the multiple cascading paths. Next is the order. Now be careful, gang. Be careful. Just like case, I did this on purpose, just like case is a reserved word, and we had to treat it differently with backticks in MySQL, order is a reserved word as well. Order is a reserved word in all DBMSs. We'd have to do the same thing in MySQL. But here we do it a little bit differently. In SQL Server, to use a reserved word, we just put it in angle brackets like this. We wrap it in angle brackets. If you don't do that, you will get an error. So please make sure you have order wrapped in angle brackets. Our foreign key is count ID. Let's take a look at it. Here's order. Here's our primary key. The contact ID right here is the foreign key. And then we have a order placed is the date time. Order placed date, order filled date is the date time. Notice order filled date can be null because we don't know when it'll be filled. And then just order notes. Okay, there it is right there. Let's look at store. Let's go to store. And we didn't have to put store there. We could put it anywhere, but it is a strong table. As I indicated, it is a strong table. At least here in this design it is. So we could put it any way we want. In our SQL, there's store. I'm not going to talk about it. Nothing really new there. We know about how to do auto increment in SQL Server, right? So auto increment is to use the identity column, or I should say the identity option. In MySQL, you say auto underscore increment. In T-SQL, you say identity. Now, one more thing, and I mentioned this way back in LIS3784. The first argument is the starting position, and the second argument is just the by how many do you want to increment. So here, we're saying start on 1 and increment by 1. Okay, we could say start on 2, increment by 2, start on 1,000, increment by 1,000. But that's what those two arguments mean. Okay, let's go to invoice. Now, let's look at invoice first before we look at the code. It makes it a little bit easier to discern that way. So here we have a relationship between contact and order, and we also have a one-to-one relationship with order and invoice. And by the way, notice that invoice can be optional. So we have a one-to-one relationship. So if an order is canceled, it is deleted, which means that it wouldn't be an invoice or it wouldn't be invoiced. So we have an optional invoice. It's not mandatory, it's optional just in case the order never gets placed as an invoice. It has two foreign keys. One is from the store ID, and also one is from the order ID. So we have an invoice ID, has its own primary key, order ID is foreign key, store ID is foreign key, invoice date is a date time, invoice total, decimal 8,2. Some pretty expensive items there. And then we're going to do a bit data type here, a bit data type. So invoice paid, bit 1, just something different. So because we could turn the bit on, we could turn it off. Here we're saying that the bit is going to be 1 by default. And invoice notes. So here is our invoice. Now notice again the invoice paid, we're making that a bit data type. And we could just turn it on or off, kind of like a flag variable. So if it's been paid, and by the way, just as an FYI later on, what we could do in a trigger is once the invoice total equals the number of payments, we could have a trigger that automatically flips this invoice paid attribute bit to 1 rather than a 0. Or either way, depending upon how you have it set up. Okay, and it cannot be null, so invoice paid cannot be null. Here is our we have our foreign keys. I also want to show you one other thing. We're going to create this one-to-one relationship with order by making order ID unique. And that's how we create that. We're saying the order ID is unique. It's non-clustered, and it is the order ID is going to be indexed in ascending order. So it's a unique index. And it's non-clustered. The only clustered index can be the primary key, and that is by default. But we're making the order ID unique. So in other words, it's going to be this one-to-one relationship. It has a foreign key, but to force it to be one-to-one, we just make sure that the order ID is unique. That way it can only be assigned, or I should say associated with one order. Okay, and again, it has two foreign keys there. Notice the data types for the various attributes here. And again, also notice the foreign keys as well too. For both of these, we're going to have on delete cascade, on update cascade. No problem here because there isn't any multiple cascading paths. One comes from store and one comes from order. Okay, next is payment. And you'll notice that payment is actually a child table from invoice. So it's going to have its foreign key of invoice ID. It has its own primary key, pay ID. Pay date is a date time, pay amount, decimal, pay notes. Anytime you can here, just for demonstration purposes, the foreign key is going to be on delete cascade, on update cascade. Nothing new here. We're making the pay amount just to make sure that it is a positive value. Now we go to more of the seller side. Here's vendor. Notice vendor is a strong table here. No, it's existent independent. Nothing new here, so I'll move on to product. Product is a child table to vendor, so it has its foreign key. Product ID is its own primary key, and product, or I should say vendor ID, Ven ID is the foreign key. One thing new here that you may have not have seen, I'm using a float here for weight. Just a float data type is a floating point data type, can have a value like 1.577, and that's the only reason I'm using that. You don't want to use floats though for currency. You want to use, just like we do in MySQL, you want to use decimal data types because it's more accurate. Float for weight, we don't have to worry about that as much, so that's why we're using a floating data type for weight. Okay. Foreign key is Ven ID, as you can see right here. Moving on, product history. Okay, there's product history. Let's take a look at it. It is a product history, so it's a child table, just like sales rep history is a child table. So product history is going to have the foreign key of product ID and its own attributes. Now, what do we need for a history table? Well, we need a date time, right? And here's our date time here. Cost, priced. So what is costing the vendor? What is the price that we're going to set for it? Any discounts and notes, and there's the foreign key. All right, let's go to the order line table. The order line table. Now here, the order line table is a child table. Not only a child table, but it's really a resolving entity to a many-to-many relationship between order and product. An order can have many products. A product can have many orders. By the way, notice, gang, don't be misled here. Product, there's no relationship to payment. That relationship is actually going underneath payment to order line. So a product can have many orders, or be on many orders, and an order can contain many products. That's why we have this order line. Okay, so here's the order line right here. Now, again, notice that we have to use the bracket delimiters on any reserved words like order, so we have to do that, okay, because it references the DBO order table. We have to put brackets around it, otherwise we have errors. And here is our table for our table definition for order line. That's it. Order line ID, its own primary key. It is auto increment using the identity option. Order ID is a foreign key. Product ID is a foreign key. Order line quantity, order line price, and order line notes. So again, here is our definition here for the order line. table. And then we could select all to make sure that we actually have all of these tables created. Now, I'm not going to go into the hash bytes right now. I'm going to do that and the insert statements in another video. But I'm just going to include all of this code that we've talked about here to date. So I'm going to populate, do all this, populate everything all the way up to, whoa, too much, all the way just up to the select statement on the information underscore schema database, and show you what we created. I'm not going to include any data right now. I'll do that later, and I'll also show you about how to do the hash bytes. Copy that, put it into, I have my remote labs open, Control V, and then F5 to run it. And there are all my tables, just like that. If I want to see it in a different view, I could right-click on here, go to Results to Text, then just run it again. Because I dropped the database, I can re-drop it again. And see, you have to scroll to see it like that. That's why I chose, instead of scrolling, I chose Results to Grid. So I'm going to do that again. Right-click, Results to Grid. Now, if you want to permanently change it, go to Tools, go to Options, go to Query Results, and then click on Query Results. And then if you want to permanently change it, like I did, just the default, by the way, is Results to Grid. But if you want to say Results to File or Results to Text, if you want to permanently change it, just do that. If you want to temporarily change it, you could just right-click on the white space there, and I'm going to do Results to Grid here again, and then I'm going to run it, F5, and there are my results. There's all my tables. All right, gang? If you have any questions, please post them to the discussion board, ask them in class, or send me an email. But the discussion board is the preferred way because someone else might have the same question. All right, gang. See you in another video.